found evidence from rocks to ashes to prove its once active days. Volcanoes, worshipped by some, feared by others. So far, all we know about volcanoes is that they've been on this planet way before plants, dinosaurs, and humans. But what caused these devastating mountains in the first place? What are the driving forces behind them? This documentary unearths how volcanoes came to be, as well as the mysteries of Taal volcano, one of the most active volcanoes today. To learn about the driving forces behind the creation of volcanoes, we need to learn a little about plate tectonics and the different plate margins. The Earth's crust is the skin between our world and vast expanses of magma. It is constantly shifting, moving, depleting, and renewing itself. It achieves this by being divided into several plates of crust that are pushed and pulled by convection currents in the mantle. Heat from the core keeps the rock in the mantle in liquid form. It convects as heat is traveling through the magma and cools again. These provide currents that can move the tectonic plates around. Plate margins are the areas of interaction between tectonic plates. These can be the source of volcanoes, earthquakes, and tsunamis. There are convergent collision plate margins, which is when tectonic plates of equal density crash against each other. They push up against each other and create new mountain ranges. Examples of these are the Canadian Rockies in North America and the Himalayas in Asia. There are divergent plate margins, which is when the tectonic plates move in the opposite direction from each other. The lithosphere diverges, and the magma beneath flows upwards, filling the gap and forming new areas of the Earth's crust. This creates fissure volcanoes caused by magma rising, as well as triggers earthquakes. There are also conservative plate margins, which is when plates slide by each other, not damaging either plate. However, this causes the rocks in the area to be affected. An example of this is the San Andreas Fault located in California. Last but not least, there are convergent destructive plates. This happens when a continental and oceanic plate interact. Since the oceanic plate is heavier than the continental plate, it is pushed under. This is called subduction. The subduction zone is right between the continental plate and the oceanic plate. There, the immense heat and pressure is enough to melt rock. Once the rock is melted, it sinks back into the mantle to be recycled.
Oh my gosh!
Continue to erupt, blasting through the thick blanket of ice. It must have been an extraordinary time.
Taal lies on destructive plates and conservative plates. At the south of Taal, there is an active subduction zone, wherein the convergent destructive plates interact. But to the north of Taal, there are conservative plate margins, which lie in an inactive subduction zone.
But how was Taal created?
You see, in a convergent destructive plate margin, the tectonic plates tend to rub against each other a lot. Since rock is a solid, constant rubbing and moving causes it to crack, and fissures form in the tectonic plate or crust. Magma can find its way through these cracks until it reaches the surface. When it does, volcanoes form. Now we know that Taal was created by a convergent destructive plate margin.
So,
We need evidence that suggests that Taal is an actual volcano. There have been numerous eruptions in Taal since 1562. 32 eruptions to be exact. The latest eruption was in 1977. But here's some actual physical evidence that we found on the Taal volcano itself. Taal Lake is actually a huge caldera that spans 15 by 20 kilometers in circumference. A caldera is an oval-shaped crater that is created from the eruption of a volcano. The size of the current Taal caldera hints that it was once a steep volcano that had a massive explosion. Thanks to our complex mathematical algorithms, we can estimate that the Taal volcano blew off 1.5 cubic kilometers of earth when it erupted. When we were in Taal, we noticed many types of tephra, which are rock fragments and particles expelled from a volcanic eruption. Boom! Igneous rocks are formed when magma cools down and solidifies into rock. They can be classified into two groups based on where the rock forms. There are intrusive igneous rocks that form below the Earth's surface, and extrusive igneous rocks that form above the Earth's surface when lava cools rapidly into rock. Examples of these are rhyolite, obsidian, scoria, and basalt. We found evidence of basaltic rocks during our investigation. Fun fact: below the surface of the volcano, molten rocks are referred to as magma. We only call them lava when they are released from the crater. We found ash. Such ash could only have gotten there after a volcanic eruption.
Say what?
This is because when volcanoes erupt, massive clouds of ash burst from their core due to the immense pressure that built up inside it. Ash from previous volcanic eruptions is clearly visible throughout the surface of the ground in the caldera.
Oh, I get it now.
now that we know that Taal is a volcano,
We need to know the hazards that the community living around it have to face.
The falling of tephra during an eruption.
ouch!
Acidic water. The water acidity of Taal Lake is about 2.7 pH, and that is very acidic.
Say what?
This is because when magma rises, it contains gases that are released into the atmosphere because they are attached to the tephra ejected from an eruption. Some of the harmful gases released by magma include carbon dioxide, sulfur dioxide, and hydrogen chloride. This can also trigger acid rain. Pyroclastic flows during an eruption. Pyroclastic flows are huge, heated ash clouds that contain volcanic rock and debris. They move rapidly in response to gravity. Pyroclastic flows are extremely hot and fast and could easily suffocate people. Earthquakes. These are normal in places near volcanoes because remember, volcanoes lie on plate margins, which can cause earthquakes. Landslides. These are caused by the deterioration of the cone of the volcano during an eruption or rain that happens after an eruption. Other hazards include lava flow, tsunamis, and lightning. Fun fact: volcanic eruptions can influence the weather and create weather of their own.
Well, that was depressing.
But volcanoes aren't all that bad. If they were, there wouldn't be people living near Taal. However, there still are. There must be some good reason for as to why living near Taal is beneficial.
Tourism. As the volcano is historical, many tourists are attracted to Taal volcano to hike, trek, and explore. This generates income for the locals.
Oh, I get it now.
Vegetation. Ash emitted from the volcano during an eruption can form an ash layer that eventually is converted into fertile soil. Soil derived from organic volcanic materials have nutrients in them, hence the land is fertile. The benefits are that farmers around the area can grow their crops to make a living.
Fishing. Water is nutrient rich from volcanoes. Nutrient-rich water provides good spawning grounds for freshwater fish. Fishermen have built underwater contraptions to catch fish so that they may be available on the market.
Volcanic activity. Taal volcano can provide resources for energy extraction, also called geothermal resources. Heat from the earth can be converted into energy.
Say what?
The big advantages of this type of energy are that it is very eco-friendly, clean, and its resources are close to inexhaustible.
Oh my gosh.
Ate, kasi takot ka ba sa isa pang eruption? Takot ka? Dahil dito nandito lahat ang aking mga anak. Magkakasama kami. Kung mga bata pa mga anak mo. Malalaki na naman. Kaya lang, siyempre pag bigla, hindi mo masisigurado kung kasama mo silang lahat. Dahil minsan gabi eh. Gabi ang gabi. Pag nalinggo dito, minsan gabi. Ate, yung anong ginawa niyo nung 1977? Dito pero dito ka na. Pero maliit pa lang ako. 1971 ako pinanganak eh. Hindi, wala pa ako. Maliit ka pa lang. Pero yung mga magulang ko, dito na talaga sila.
So yung mga lola niyo pa dito na sa Taal?
Doon daw pumutok noon, doon dinala mga tatay ko sa Palawan.
This is amazing!